So good afternoon and welcome to our tea party, Steep the Chemistry of Tea. And welcome to the Institute for Religion and Science. It's an organization that was founded in 2011, and we've been going strong up and down during COVID, but since that time. And so we found somebody tonight who is absolutely an icon of religion and science. She's steeped in both. She's steeped not only in tea, but in religion and science. The other day, someone sent me this quote from Thich Nhat Hanh, and I thought it would be an interesting way for us to start. He says, "Drink your tea slowly and reverently, as if it is the axis on which the earth revolves." So while we begin, once Michelle begins, just do that, listen and enjoy the tea. And when the talk is over, then we'll going back to the tea party and have the rest of the tea party. But in the meantime, and if you want to get up and refill or whatever, please feel free to do that. So it gives me great pleasure to introduce Michelle. Dr. Michelle Francl serves as Frank B. Mallory Professor of Chemistry at Bryn Mawr College, where she teaches and does research on topologically intriguing molecules, also known as molecules with weird shapes. A quantum chemist, Michelle has worked in areas ranging from the development of methods for computational chemistry to the structures of topologically intriguing molecules. She was elected a Fellow of the American Chemical Society in 2009 and is the 2019 recipient of the American Chemical Society's Philadelphia Section Award, which recognizes an individual who, by conspicuous scientific achievement through research, has made important contributions to our knowledge and has thereby aided the public's appreciation of the profession. Her essays on science, culture, and policy appear regularly in Nature Chemistry and other venues, including Slate. She also gives occasional workshops on writing for scientists and blogs at the Culture of Chemistry. In 2016, Michelle was appointed as Adjunct Scholar of the Vatican Observatory, where both her science and her faith collide. Michelle Francl Donai, who is the same person but sort of an alter ego, is a writer, a teacher, a wife, and the mother of two 20-something sons. Her reflections on struggling to live a contemplative life in the midst of the everyday chaos that comes with being a working wife and mother can be found in a number of print and other venues. On January 24 of this year, Michelle became a superstar. That was the day her book, Steeped the Chemistry of Tea, was released. Although the title sounds harmless enough, and perhaps maybe even boring to some non-scientists, Michelle's suggestion that adding a pinch of salt could mitigate bitterness in tea caused strong reactions in the United Kingdom, including one from the United States Embassy in London. So those of you who dare to pick up the book, and I know some of us have, will find it a compendium of little-known facts about caffeine and the other almost 1,000 chemicals that give tea its flavor and make it the world's most popular beverage. Beginning with the leaves, Steeped explores the chemistry behind different styles of tea, from green teas to pu'er. It tackles the age-old question of when, and even whether, to add milk, and it puts chemistry to use with advice on how to brew a better cup of tea. This afternoon, I feel we are very privileged to have Michelle here in person with us so that we can learn more about tea's history, its composition, and learn how to make the best cup of tea there is. So please join me in welcoming my dear friend, Michelle Francel.
So I'm going to thank Kathy for that introduction and ask, can everyone hear me? If you can't at some point, wave briskly. So as Kathy said, I write in a lot of different places about a lot of different topics, but tea is one that is near and dear to my heart, so it was really fun to work on this book. And I want to start a little bit with, where did the book start? So maybe one starting point for the book was in 1885. So I was working at the Othmer Library, which is in the Science History Institute in Philadelphia, down by the Liberty Bell. And I was looking for other things in the literature, but I was just browsing through this journal from 1885, and in it I found this paper that was entitled On the Infusion of Tea. And the really interesting thing about it to me, aside from being about tea, which is what I love to drink, is the author, Wilhelmina Green. In 1885, here is a woman chemist who is not a co-author with her husband or her brother on a paper, but solo authoring this paper, which is this very careful and beautiful classical analytical chemistry analysis of tea. I will say that if you read this, you will discover that in those days, you used things like brimstone to analyze tea. And I'm trying to imagine what that must have smelled like. Probably not great. But she said people didn't know a lot about tea, and particularly its infusion, despite the fact it was, by that point, pretty much the national beverage of Britain. Or the story might start in 1976, when I was an undergraduate, so now you can guess how old I am. And the person in the photograph is Sherry Rowland, who won the Nobel Prize in Chemistry for the ozone layer. And he was my general chemistry professor, my introductory chemistry professor. And at that point, he was testifying in front of Congress, but he was also a fabulous teacher, and I learned a great deal from him about how to teach. And one thing he was accessible to his students. He would have office hours and encourage us to come. So there I am, this little 18-year-old showing up with my questions about the pH of something. And here is this person who would eventually win a Nobel Prize, patient and happy to answer my questions. But he was renowned for his very odd exams. So if you've taken a general chem course or a physics course or a math course, you know that the exams are usually a bunch of problems to work that look like your homework, more or less, right? No. This question was 4 questions, one of which was this one. And of course, all these years later, I still remember them. The color of tea lightens perceptibly when lemon is added. Why? Give the appropriate chemical equations. And my first response to this was complete and total panic. Like I had no idea how to answer this question. Like, was I in the right class? And then I calmed down enough to realize the professor is a good guy. He wouldn't ask us something we couldn't answer. So what do I know? I thought, we'd studied indicators, which change color depending on the pH. And it turned out that's what it was. And once I had that key, I was set to go. But it made me feel for the first time like a real chemist, like someone who could solve a real world problem. Or maybe the book starts in 2020 on Twitter. So this question appeared January 3rd on Twitter in 2020. Chemistry question for ChemTwitter. ChemTwitter is a pretty active group of chemists on Twitter, a little less active since Twitter has turned into X, but still, we're there. Is there an extractive advantage to the tetrahedral tea bag over the traditionally shaped one? And I brought some tetrahedral ones if you want to try them. They're over there labeled PG Tips. Or does it look cooler? Well, chemists think that tetrahedron are just cool. So yeah, for us it looks cooler. But the thing got me thinking, what do chemists know about the making of tea? And what do we know about tea bags? Anything? It was between semesters. I write this regular column for Nature Chemistry, and I thought, I'll go look in the literature. What do we know? Turns out chemists know a ton, like a ton about tea. And so I wrote a 2-page essay for Nature Chemistry, advice for chemists based on chemistry about making a good cup of tea. A little bit tongue-in-cheek, a little bit snarky, and out it went. But if you think about 2020, what happened in 2020? We had a pandemic, right? So this essay came out right before we all were locked down for the pandemic. And Nature sent out the article to its whole mailing list and said, we are locked down, we are stressed, everyone needs to chill out and make a cup of tea. Here's some advice, which is great. And then an editor for the Royal Society of Chemistry Press looked at it, Helen Arms, and Helen sent me this email message that said, loved your essay. Can you turn it into a book? The essay is 2 pages long. She was looking for a 200-page book. I'm like, Helen, I have no idea. And we're having a pandemic, and I'm chairing my department, and we're trying to go online teaching. So yeah, maybe. She says, I'll send you the information about a book proposal. 5 weeks later, she sent me back another email. Did I scare you off? I'm like, oh, Helen, I have been just drowning. I said, but maybe I'll look at it. So I did at the end of the semester and decided, yeah, I could maybe turn this into a book. And so the work for writing Steeped began. I wired up my, you can see it. So the green teapot, I wired up my teapots with temperature sensors. I used constant temperature baths, the things with all the orange ping pong balls on top of them. I wrote and wrote and wrote in my little office upstairs. And eventually I had a stylist style the pictures. When I told my sister I was having a stylist take the pictures, she said, oh, you'll look great. Like, the pictures are not of me, Denise. The pictures are of the tea. And the tea does look fabulous, I'm going to say. And Andrew DiDonato, who did the photography for this, is very talented, and the pictures are just gorgeous. So this is what happened. The book is called Steeped, The Chemistry of Tea, and here's the table of contents, everything from a cup of chemistry to sugar and spice, and earth, water, fire, and air about tea bags and teapots and teacups. What do we know? So come the 24th of January, I woke up first thing in the morning, and in my email was a nice email from Helen, my editor, which says, Dear Michelle, congratulations, Steeped is officially published. And at the end of this just standard, like, run-of-the-mill email that they automatically send comes this advertising your book. We do as much as we can to raise the awareness of your book, but you should do some of the work too. Share a link, share the good news on your website, social media perhaps. Tell us about relevant conferences. So I point out the time. This is 6:56 in the morning. 7:41, it's less than an hour later, and the US Embassy has a press release. And it says, today's media reports of an American professor's, that would be me, recipe for the perfect cup of tea has landed our special bond with the United Kingdom in hot water. Tea is the elixir of camaraderie, a sacred bond that unites our nations. We cannot stand idly by as such an outrageous proposal threatens the very foundation of our special relationship. Therefore, we want to ensure the good people of the UK the unthinkable notion of adding salt to Britain's national drink is not official US policy and never will be. Let us unite in our steeped solidarity and show the world that when it comes to tea, we stand as one. The US Embassy will continue to make tea in the proper way by microwaving it. So you can tell from beginning to end, this is very tongue-in-cheek. So by the time, I'm meanwhile in the shower and driving to the college, and I have no idea any of this is happening until I'm sitting in a departmental meeting and an email flashes across my laptop screen that says New York Times request for comment. I'm like, uh-oh. So I open it up and realize, something is happening. So I leave from my office and I discover this. And yes, the New York Times would like some comments on it. But meanwhile, my sister has seen it. And she says, is this real? I mean, a good bump for your book, but surely this isn't real. It was definitely real. Eventually, the Home Office, so the Prime Minister's office of the UK responded, and a lot happened. In fact, so much happened, it was hard for me to keep track of it. So that's the list of interviews and phone calls that I did over the next 2 days. I slept a little bit. So there was a lot of kerfuffle about it. It was NPR and the BBC. The Daily Mail got hold of it. I got hold of it twice, so that's a tabloid in the UK. But I'm going to say maybe for me the best part was I was a limerick on Wait, Wait, Don't Tell Me. So if you follow that NPR show, I was a limerick. Before all you Britons find fault, take a sip and your whinging will halt. While sugar is not nice, it's not quite the right spice because your tea needs a wee pinch of salt. And that was the advice that set it off, is that the one weird piece of advice I had about tea was a dash of salt will make the bitterness less if you're finding your tea too bitter. And sometimes if you just oversteep your tea, you can make a new cup or you can put a tiny pinch of salt in and that will help. And I was very proud of this fact because tracking down the chemistry behind it turned out to be pretty difficult. And when I finally did, I felt like, this is a piece of information I am proud of. And it turns out it's also the piece of information that made all of Britain really mad at me. So what do I want to talk about? So I want to talk about tea, which comes from this one particular plant, Camellia sinensis. So there's lots of herbal teas, and I'm not going to talk about those, but I really am going to talk about tea that comes from this one particular plant. And maybe I'll stop and say, too, that if you want to get up and get another cup of tea while I'm talking, you should feel free to do that. There's lots of different teas over there to try. So that's what I'm talking about. And in fact, tea is named for the camellia plant, which is named for a Jesuit botanist from the Philippines, George Kamel. He came from the same place in what's now Austria that Gregor Mendel came from. So there was a lot of kind of activity in that area around botany. And he went to the Philippines as a Jesuit brother. He was a pharmacist. And he turned out to do an incredible amount of research around the plants of the Philippines in that area. He never once did anything with tea. Even though the tea plant gets its name from him, he never did anything with camellias. What he did do, among other things, was write this paper about the Faba Sancti Ignazii, which turn out to be, they're called St. Ignatius's beans, and they contain strychnine. Which at one point was part of the pharmacopoeia. Like people gave people strychnine and they extracted it from these beans. So Steep starts out with a cup of chemistry because if you're going to talk about the chemistry of tea and you don't know any chemistry, you need to know some chemistry first. But I wanted to make sure that the chemistry was accessible. I test drove it on my sister, who does not like chemistry, but does like tea. She said her eyes did not glaze over too much. But I was trying to write the book for two audiences, for an audience of chemists, but also for an audience of non-chemists, and have it work for both. And this was kind of a fun challenge. So the way I worked it for non-chemists is I thought about what are the really big ideas of chemistry. And I cut it down to 4 big ideas of chemistry. Do not tell my general chemistry students this, right? They spend a whole semester with me, but really I'm going to tell you in like 4 minutes everything they need to know. So the 4 big ideas is, the first one is that all matter is made up of atoms. So atoms make up everything, don't trust them. Opposite charges attract each other, like charges repel. Materials have to get close together to each other in order to react, so proximity is important. And finally, the last one, which is the one that I hope that my students take away from the whole semester. If this is the only thing they remember, I'm happy. Molecular shape is what controls molecular function and molecular properties. So these are the 4 big ideas for non-chemists. Meanwhile, how do I keep the chemists entertained? They have a bunch of little asides and footnotes. I brought the receipts. In other words, you can look up the references if you want them. So it should be readable by chemists and give them an on-ramp about the chemistry, but should also be accessible to non-chemists. So there's a whole chapter about this, but not everybody wants to read the whole chapter. So there is a too long didn't read, 3 paragraphs, everything you need to know. And I'm going to read this in part because I love the last line, and I worked really hard to be able to say it, so I'm going to do that. Matter, including everything in my cup of tea, is made up of atoms. Electrons are the glue that hold atoms together. The behavior of materials depends on the arrangement of the atoms not their source, whether natural or synthetic. I mean, think about those wonderful St. Ignatius beans. Those are all natural strychnine. Atoms can be rearranged to make new materials. And when we make a cup of tea, atoms are rearranging to make new materials. Most of the molecules I discuss in this book are built on a carbon atom framework decorated with hydrogen atoms, oxygen atoms, and nitrogen atoms. This is what chemists mean by an organic molecule. So when chemists talk about organic things, we're not thinking about organic farming. Molecules can react with each other when they get close, and many reactions can be understood as interactions between positive and negative charges. In the chemical world, opposites really do attract. Molecules can also hand off electrons from one to another, a process called oxidation. And tea is a good antioxidants, and we'll talk about that. So chemists show the framework of carbon atoms by drawing lines, and a hexagon is really 6 carbon atoms in a circuit. We generally don't show the hydrogen atoms. Long, tongue-twisty names are often compact instructions for assembling the molecules. And here we go. Most chemical names contain, for chemists at least, clues to the structure and therefore the function of the molecule. With no apologies to Shakespeare, 2R, 3R, 4S, 5S, 6R, 2, 2S, 3S, 4S, 5R, 3,4-dihydroxy, 2,5-bis, hydroxymethyloxylin, 2,il-oxy, 6-hydroxymethyloxane, 3,4,5-triol, by its other name, sucrose, table sugar. Tastes just as sweet. There we go. Don't ask me to do it again. And don't ask me to do it without my cue. So what is a molecule? A molecule is just a group of atoms that are attached to each other, held together with that glue that is the electrons. Ions are molecules that have a positive or negative charge. And that molecule back there is caffeine. Chemists, when they think about a molecule, have a lot of different ways about thinking about that molecule. So for example, they can think about it with a little line structure. They can think about it as a space-filling structure. They can just list the atoms in it, C8, H10, N4O2. Or they can think about the reactivity, that kind of green blob with the red blob on it. The red areas are reactive, the green areas are not. So we can think about molecules in a lot of different ways, but if we actually look at a molecule, it doesn't look at all like this. If I could, focus a microscope on it, it would look more like this, like a fuzzy bunch of little balls attached by small sticks. So this is not caffeine, but is a molecule that's the start of graphene, graphite like in a pencil. So that's all the chemistry you need to know. Things have to get close to react, positive and negative charges attract each other, and the structure is related to the function, and atoms are the key. So let's see what that means. So back to our plant, and it's one single plant makes all those different kinds of tea. So over there I have white tea, green tea, black tea, oolong tea, pu'er tea, white tea, there's yellow tea, I didn't bring any yellow tea. And all of these different kinds of tea are up there. There's matcha tea, powdered green tea. There's the kind of tea that gets bound together with flower leaves that you can make bloom in a pot. That's in there. And so all of these different kinds of tea come from a single plant, and it's just processed differently. So the chemistry begins as soon as you pick the leaves. So here is a flow chart for how you might get to the different kinds of tea. Everything starts with fresh tea leaves that you pick. As soon as you pick them, chemistry starts happening. The first thing that happens is you might let some of these teas wither a bit. In other words, you just pick them and just lay them out on the ground or actually on a net, typically. And that will eventually give you black tea, oolong tea, white tea. If you have green tea, you don't let it wither at all. You just grab it and immediately heat it up. You fire it, pan it, steam it. You just need to heat it up. And what you're trying to do is what they call kill the green. And what you want to do is not actually change its color, but you want to destroy enzymes in it so that no more chemistry will happen. On the other hand, if you're going to make black tea or oolong tea, you want to deliberately bruise the tea. So you let it wither for a couple days, and then you get it in and you bang it up deliberately. And if you think about it, most of the time when you pick things, right, you're trying to be very gentle, not damage them. Here you want to damage it for sure. Once it's been damaged, then you want to, again, heat it up or just continue to let it dry and shape it. So that's how you get those little green snails over there. Someone's taken green tea and shaped it. And then there's kind of a fun thing, pu'er tea. Pu'er tea has been deliberately inculcated with mold. So that's really moldy tea, and I'll talk a little bit about how that happens. And then in the end, you might let that moldy tea kind of ferment, like kimchi, and that eventually produces these pu'er teas. So that you get 6 different kinds of tea from the same leaf just by leveraging the chemistry. So it's like a little bit more. So there's the banana for my lunch a few weeks back. It's bruised, right, because it was in my backpack. And my mother would say, if I said I didn't want a bruised banana, my mother would tell me, eat the banana, right? Or eat the bruised apple. It's the same chemistry that bruises the apple, that bruises the banana. It's things called polyphenol oxidases. And what they do is they take the antioxidants, the epigallocatechin that's on the left-hand side, and it turns them into something called thiorubigens. And when it does that, it gives that brownish color, which in a cup of tea is that beautiful brown-red color in your cup of tea. You don't want it in your bananas, you don't want it in your apples, but you definitely want to take advantage of the trauma and use that to make the tea the beautiful color that it is. There are other enzymes in there too. There's beta-carotene in tea. We think of that as carrots, but it's in your tea too. And another one called neoxanthin. And the beta-carotene gets turned into beta-ionone, which smells and tastes a little bit like violets and raspberries. So that kind of gives a floral scent to the tea. And that can turn into theospirone, which is another kind of fruity piece of the tea. Neoxanthin gets turned into beta-damascenone, which smells like roses. So I have a rose tea over there, which is kind of doubly rosed. There's rose scent in the tea itself, plus the scent from the roses. But it's also the scent in whiskey, or one of the scents in whiskey. So there's a relationship between whiskey chemistry and tea chemistry. You might have heard the Maillard reaction. When you think of the Maillard reaction, often what you think of is a good steak, because that's what gives the nice crusty brown coating to a steak, or what browns cookies in the oven. But it's also happening in tea, and it's one of the things that you can look at because it is a positive charge and a negative charge. You need something with an N, a nitrogen in it, and you need something with a carbon and an oxygen, the C and the O. The C has got a positive charge on it, the nitrogen a negative charge, and what did I say about opposite charges? They attract. So they attract and they make a new bond, new structure, new behavior. So some of the things they can make are thiophene and thiazole. And chemists know that things with sulfur in them often kind of smell a little bit. And you might notice a little bit of sulfurous smell to a tea, especially a black Assam tea, has a little bit of a sulfurous smell or a little bit of a kind of smoky smell. That's coming from thiophene and thiazole and from the Maillard reaction. All natural does not necessarily mean all safe. So furan and acrylamide are both known to be cancer-causing agents. They are in coffee, they are in tea. They come from the Maillard reaction. The furan gives it a spicy cinnamon-type flavor. Acrylamide you can't taste, but they are both present in tea. They're one of the thousands of compounds in tea. So pu'er tea and microbial chemists. So it's a black mold, but not the kind of black mold that people worry about finding in your walls. If you've seen a kind of the black dusty stuff on onions maybe, that is Aspergillus niger. And it's called Aspergillus because it looks like an aspergillum, which is what you use in the Catholic Church to sprinkle holy water. And the person who discovered this was a mycologist who was also a priest, Pierre Mitelli. So that's the statue of him. He was from Tuscany, and he identified this mold. And you can sort of see, right? It kind of looks like water coming out of an aspergillum, hence the name. And it's a whole family of things. But what it does is it takes apart some of the things that are in tea and oxidizes them. It chews up all of the L-theanine, which is a compound in tea that is often thought to be calming. So pu'er tea should be slightly less calming than your average tea. So this is the point that we get to, the drug in the cup. So what's the drug in the cup? I love this quote from Lu Tong's Song of Tea. The first cup moistens my lips and throat. The second shatters my loneliness, maybe or maybe not. The third causes the wrongs of life to fade gently from my recollection. The fourth purifies my soul, but here we go. The fifth lifts me to the realms of the unwinking gods. Which if I have tea after 4 o'clock in the afternoon, I'm definitely, alas, unwinking at night. So people have known about caffeine's effects for a very long time. And caffeine turns out to be how the plant is a recycle, reuse kind of thing. When DNA and RNA are synthesized or broken down, you end up with adenine and guanine, and that gets turned into something called xanthosine. And xanthosine has got that 6-membered ring, so it's got a hexagon with a pentagon kind of attached to the side, a little tail hanging off of it. And in the body, or in the plants, there's a gene. We've identified the gene. The gene's in coffee, same gene in coffee, same gene in tea that creates the caffeine. It's in a number of other plants. Interestingly, there are plants all over the world that synthesize caffeine, except in Europe. Europe is the only place that has no naturally occurring plants that synthesize caffeine. So Europe was decaffeinated until about the 1600s. And people have argued that the Renaissance sort of like flourished because caffeine finally made its way to Europe and everybody woke up. I'm not kidding. Michael Pollan has a whole essay about this in a book about plants. So it turns out that caffeine is made by all these plants, so it must do something for the plants. Like the plants don't make caffeine for us, as delightful as it is in the morning. They make it because it's a pesticide. So, essentially what we're doing all here is extracting pesticides and herbicides from these leaves and then drinking them. It does it by first clipping off that little tail, and then there's a system that puts one of these methyl groups on that I've highlighted, and then it puts on another one, so 2, and then it puts on 3. And so what you end up with something called trimethylxanthine, that's another name for caffeine, and it's also sometimes just called trimethyl. And it turns out this is the first drug that was implicated in drug doping scandals in sports for cycling at the end of the 19th century. Somebody was doping the cyclists with caffeine. So how does caffeine work? So it turns out that it works because it binds to a particular receptor in our cells. So when you get tired, adenosine binds to this protein. So adenosine is up in the corner up here to my right, or to your right, my left. And when it binds to this particular protein, this protein sits half inside the cell, half outside the cell. So adenosine binds, and then it causes the part inside of the cell to essentially twitch, like twitch a tail on a cat. When it does that, that physical switch kicks off a whole bunch of things that says, hey, you're tired, you should take a nap or go to bed. But caffeine is like a molecular bully. And this is part of this, there we go. So it binds right in there. It slides in with the 6-membered ring, kind of deep inside the pocket. Oops, I'm gonna go back. And you can see that you've got the same shape in both the adenosine, which lets you sleep, and the caffeine, which will block it. And once it sits there, it doesn't want to come out. And so the adenosine can't get in. And when caffeine binds, it doesn't kick off that little switch. And it says, you're not really tired, just stay awake. So in fact, I think, here we go. Anything with this kind of motif, with this 6-membered thing with a 5-membered thing attached to it, will bind in that space. So here's another compound that someone's made that should also bind, right? Because it has the same structure. So this is part of structure and function are related to one another. And there it is. It can go slide right in. And I'm going to go back to the previous slide for a second. There we go. So if you look at that orange box, right, the caffeine binds in the top half, but there's an empty spot at the bottom, right? I could slide something else in there. So if I go make this molecule here, I can make it with another tail on it, and that tail can slide into the empty spot, and when it does, it binds 10 times more tightly than caffeine. So this is essentially a super caffeine. I showed this to my students in a class, and they're like all excited. They're like, a super caffeine? Has anyone taken it? Will it keep you awake longer? The answer is yes, it will. But it's not being developed to keep college students awake for their midterm exams. Instead, it crosses the blood-brain barrier. So caffeine is one of the few molecules that will actually get into the brain. And so these sorts of things are being explored as potential drugs for Parkinson's disease. So it's not to keep the students awake. Oh, maybe I'll say one more thing. If you would prefer the caffeine not keep you awake, if you eat more brassica vegetables like broccoli and Brussels sprouts, that will make your body clear caffeine more quickly. I announced this at the dinner table one night. My son, who's a graduate student in math, said to me, I hate to break it to you, Mom, but that's an old person thing to think about. He said, I would like to know how to make the caffeine last longer. Definitely not something I want. But how do I make it last longer? Turns out if you drink grapefruit juice, in the same way that sometimes grapefruit juice interacts with the statins, it can also interact with the things that break down caffeine. Prevent them from breaking down the caffeine, it lasts longer. So if you have a glass of grapefruit juice in the morning, that will make the caffeine last longer. I said this in a seminar I gave that a reporter was at, who then tracked me down to say, how much grapefruit juice do you put in your tea? I'm like, none, not in my tea. He goes, but how much in the tea? I'm like, not in the tea. Because I was afraid that we were gonna go right back to the whole salt thing again, right? But so far they will let me into Britain. So the taste of Zen. There are, as Kathy said in her introduction, more than 1,000 different compounds that have been identified in tea. Some chemists think there are maybe as many as 2,000 distinct chemical compounds in a cup of tea. So what are some of them? There are the catechins, which are these antioxidants. There's caffeine, there's L-theanine, which is sometimes called the Zen molecule. It actually is an anti-anxiety if you give it to people, not with clinical anxiety, but subclinical anxiety. If you're having a stressful day, a little L-theanine will make you feel calmer. Theaflavins, theorubicins, and theobrownins, which give the color and the aroma to the tea. There are other alkaloids. Theobromine is in there, like there is in chocolate. There's quinine. So there's other alkaloids in there. There's fluoride. There's inorganic fluoride, F-, the same stuff that they put in the water. And it turns out this is the biggest dietary source of fluoride. It's also weird because most natural compounds of fluoride are toxic, but this is not. And there's only 2 organisms in the entire world that we know of that secrete fluoride, the tea plant and a weird sea sponge that grows only in New Zealand. Go figure. There's aluminum in there. It's the biggest dietary source of aluminum. There's iron. Turns out the iron is completely inaccessible to us. So if you know, it's like spinach. It's not a great source of iron, even though there's a lot in there. I hasten to tell you there's uranium in your tea. Not enough to cause any real issues, but someone has analyzed the radioactivity of tea. There's organic acids like oxalic acid. If you have kidney stones, sometimes they tell you not to drink tea because it has oxalic acid in there. It's the same stuff that's in rhubarb. My mother told me when I was a kid, do not browse in the rhubarb patch and eat the rhubarb leaves. I had no desire to eat the rhubarb leaves, but my mother, it was very clear, don't eat the rhubarb, it's poisonous. Oxalic acid is poisonous. There's not enough, it turns out, in rhubarb leaves to poison you, and there's not enough in tea either. But there's more in tea than there is in rhubarb. There's insect DNA. There's the DNA of 400 different insects has been identified in commercial tea, just the kind like Lipton that you buy. And while that might seem like a little like, it's not whole insects, it's just their DNA. And it sort of says it's a natural product. right? That this is grown and not too much pesticide has been used on it. So insect DNA is actually a sign of health in all of this. You might ask yourself, of all these thousands of compounds, what are they all doing in there? And it turns out you don't need all 1,000. So I am a fan of Star Trek, as you can probably tell from this slide. And there are days when I wish that the replicators worked, where I could just stand there and say, tea, probably not Earl Grey, but I would pick something else, tea Assam hot, and have it just appear in front of me. Or, you know, my sandwich for lunch could just appear in front of me. But how would that work? So it turns out that a group took the compounds that they found in Darjeeling tea and picked 51 of those compounds, analyzed the tea for how much was in there, and then mocked up a fake cup of tea just by mixing together the 51 different chemicals, and then asked some experienced tea tasters to taste it. And the tea tasters said, it tastes like tea. It tastes like a reasonably good cup of tea. So then they took the list down even more to this list of 12 molecules, and this actually also tastes like tea. Not a great cup of tea, but still tea. And so the ones at the top, the quercetin, the camphorol, those molecules are giving you the astringent taste, the kind of dry, puckery taste that you get in a cup of tea. And the epigallocatechin and the catechins are the antioxidants. And the caffeine is the caffeine, the drug in the cup. And it's also part of the bitter taste. So decaffeinated tea tastes kind of watery, and there's no avoiding that because you're taking out that bitter taste. The interesting thing to think about is when you make a cup of tea, it gets heavier because there's like milligrams of material that are coming out. And I always think that's weird because I put my tea bag in and I think it's just changing the color. But in fact, it's getting heavier in part because of all these compounds. The agony of the leaves. How do you make a cup of tea? I could use the fancy constant temperature bath. I could use the tea bag. I could use the microwave, right? And this is a sin in Britain. Like, people ask me, like, do people in the US really make their tea in the microwave? I'm like, yeah, we do. So sometime after this story broke, I was heating up my cup of tea because it had gotten cold, and I was heating it up in the microwave, and my husband appears and he says, caught. And he took a picture of me. So there I am, even though I'm going to tell you that there's reasons not to use the microwave. So caffeine, if you want to get your caffeine out, caffeine comes out very quickly. It's very soluble. And you can get almost 100% of it out as long as you use water that's pretty hot. And it comes out faster than the tannins do. So if you want antioxidants, you have to let your tea steep longer than it is just for the caffeine. So the caffeine comes out fast. So my cousin asked me, she says, I only have like a minute to make my tea in the morning. She's, you know, a mom of a younger kid. And she says, is it any good? I said, it's got all the caffeine in it. She says, that's good. And she said, anything else? I said, not really. She said, but that's good. But once the temperature starts dropping, it turns out you get less caffeine. And temperature drops pretty quickly. So I wired up my favorite teapot from Japan. It's a cast iron teapot, and discovered that by 50 seconds in, I'm just barely at the temperature you need for steeping, 90 degrees Celsius. And by the time it's through steeping, I'm down to 85 degrees Celsius, and much less caffeine is getting extracted. So temperature really matters. And here's another graph that shows you, again, that if you wait, the caffeine comes out pretty quickly. So you get 50% of the caffeine in just about a minute from a tea bag. Not as much of the other good stuff, but nonetheless, caffeine. All right, here's the microwave bit. So if you've made your tea in the microwave or reheated your tea in the microwave, have you ever noticed that there's sometimes a little white foam on the top? Yes, right? So I had noticed too, but didn't know where it came from. So in the course of writing the book, I decided to figure out what is it and where did it come from. It's called, I'm going to tell you, tea scum. And it's related to the scum in your bathtub. It's the same thing. What you have is organic compounds, and you have magnesium ions, some of which come from the tea itself, some of which come from hard water. And those things together make this scum. It's like a raft of these compounds that float there. You get it in the microwave because when you heat tea or water in the microwave to make tea, it boils pretty quickly, faster than it does on the stove. That's the big attraction, right? And it doesn't get enough of the oxygen out, and the oxygen helps feed the development of the scum. The scum won't hurt you. It'll make it taste a little bit less bright. If you don't like it, you can just put something in like a little lemon, and the lemon will make the scum go away. Just the same way there's stuff they make you can clean the bathtub with. It's the same chemistry. I try not to think too hard about this when I'm drinking my tea, but it hasn't stopped me from heating it up in front of in the microwave. It turns out if you've made iced tea, you notice sometimes it gets cloudy as it sits. That's a similar process, and it's called creaming. And food chemists have worked really hard to stop this from happening. If you'd like the tea to be like crystal clear when you make iced tea commercially, and it's hard to do. Sugar and spice. We have Earl Grey people in the audience, I know, people who like Earl Grey. Yeah, another Earl Grey drinker. Earl Grey tea is scented with bergamot, which is a citrus that's native to Italy. And people aren't too sure like who first started adding this to tea, and there's a lot of legends around it, some of which have to do with Earl Grey, a person named Earl Grey. But it turns out that they think people added it because low quality tea or tea that had been left sitting too long kind of loses its aroma. And if you add bergamot to it, some of the same compounds in bergamot are in tea. So you sort of refresh the tea by adding that. And one of those compounds is linalool, which looks like linalool, but it's pronounced by chemists linalool. And that compound is one of the ones that's responsible for the scent of bergamot and the scent of Earl Grey tea. It's a little perfumey. Some of these other compounds in there also are a little perfumey. But the interesting thing about linalool is that it's another anti-anxiety compound. So if people breathe that in, if you breathe in that compound, you will be less anxious. And in fact, it binds to the same kind of receptors as opioids bind to. So that if you use Narcan, you can block linalool. So it's a pretty fascinating molecule. And my husband, who loves Earl Grey tea, feels very vindicated that that's a calming cup of tea. So if you need a calming cup of tea, make a cup of Earl Grey and just inhale the vapors. You can drink it too, it's also good. Milk. Should you use milk, should you not use milk? You may be surprised, I was, to find there's an actual official international standard for making tea that tells you when and how to add the milk into it. And I'm just gonna front Muriel Baker, who's the woman up there. She was a biochemist. She was having tea with a mathematician and a biochemist who she'd eventually marry. And she said she could tell the difference if you put the milk in first or the milk in second. And the guys were like, yeah, no way. And they're like, can we test this? And how can we test it and be sure that it isn't just like lucky guesses? And so if you know what the null hypothesis is as a statistician, it's an important statistical test. It was developed to test Muriel's tea by Ronald Fisher, who eventually published this paper, Mathematics of a Lady Tasting Tea. Turns out Muriel could indeed taste the difference, and the null hypothesis let them figure out that she could. So there's some cool math and stats that comes out of this as well. The last bit is the answer to the question. So I started off by saying this book began with this question about tea bags and whether the shape matters and what do chemists know, and chemists do know. So here's this paper from 2001 that looks at the shape of tea bags, and the answer to Andre Chemist's question is the shape does not matter, only the size. So tea swells up a lot when you add water to it, and in doing so, if you have it too tightly packed into a tea bag, then the water, the solvent, can't get into the middle, and you get less proximity. So that's one of those big ideas of chemistry. Proximity is inhibited. They can't get close together, so you don't get as good a cup of tea because you don't get all those compounds out. So the shape doesn't matter, but the size does. Those tetrahedral tea bags often have more room in them. But you can also use an infuser. And so and if you use an infuser, you don't have any of the tea flavors being absorbed by the tea bag. So I brought the tea bags to use today, but those absorb a little bit of flavor, and you'd get a little more flavor out of the cup if you didn't use a tea bag but used an infuser. But the infuser also needs to be big enough to let the tea leaves expand. So here's some of my collection of tea infusers. And like teapots and tea mugs, my husband will tell you I have too many. But can you ever really have too many? I don't know. Anyway, here's my collection. And now here comes my boss at the Vatican Observatory. So that's Guy Consolmagno sitting there in the Georgetown Observatory, which is pretty old and is run by the students these days. So he's sitting up there. And I was trying to figure out how you could really assess the volume of those tea infusers. So I'll go back there. I want to know how much tea can I make with an infuser, so I need to know what the volume is, so I know how much tea to put in. But if I want to measure the volume of something, typically you pour a liquid into it. But if I pour a liquid into these, what's going to happen? It's going to go right through, right? So how do I measure the volume of those things? Well, it turns out that Guy Consolmagno and a collaborator had figured out how to measure the volume of meteorites. And typically, again, you'd put these into water or oil to see how much volume they displace, but you're not going to do that with your one-of-a-kind, 4.5 billion year old meteorite. So what are you going to do? You're going to use, so Guy had this idea when he was making a cup of coffee. Well, that's not tea. It would be a really perfect story if it were tea. But he's mixing the sugar and these big-grained Italian sugars, and he thought, oh, we can use glass beads. So in fact, I used the method from Consolmagno and Britt to determine the density of meteorites, and I use those to measure the interior volume of all my different infusers. And it turns out that the cute little yellow submarine one, which is a pain to clean, also makes a tiny cup of tea. Like I'm going to have to spend a long time cleaning the darn thing for one tiny cup of tea. No way. The owl one is cute, but again, does not make much tea. The OXO one is just like a plain stainless steel thing. It's not very fancy looking, but it makes the best cup of tea. I can make up to a liter of tea from that particular infuser, which might be what I need to get me through the morning sometimes. Teapots. Warm your teapot, always warm your teapot. Here's a whole bunch of different teapots. The best one of the bunch is the glass pot at the bottom, which is actually a coffee pot. It's double-walled, and what's in between the walls is as close to nothing as you can get. So there's no way for the heat to kind of move out. It needs to interact with something, another proximity issue. The worst one are the beautiful ones from Japan. I bought one of those in Kyoto on a field trip with students. We were spending 2 weeks with just what we had on our backs, staying at various Buddhist monasteries. So we were carrying all the stuff around. I bought that teapot on day 2 and spent the next 2 weeks carrying it all over. It got heavier and heavier as we went. So I'm very invested in this teapot, and I love it. It's beautiful, but it cools off the tea pretty quickly. The one on the top with the kind of silver thing hanging there, that has a built-in tea cozy for keeping things warm. So the stainless steel part is lined in felt. So what about a perfect cup of tea? The perfect cup of tea is what you want in a cup of tea, and the book is intended to sort of tell people how to tweak your process to get the cup of tea you really want. You want caffeine in there? High temperatures. Definitely use a high temperature. If antioxidants are the reason you're drinking tea, time and agitation. Let it steep longer and bounce the tea bag up and down or stir the tea leaves around in the infuser. If you want a calming cup, L-theanine. And again, the longer you let it steep, the more L-theanine will be in there, or choose Earl Grey or Lady Grey tea with the bergamot in them. Pre-warm your pot or mug. Even if I just make a cup of tea, even if you're just using a tea bag, run the cup full of hot water from the tap and let it sit for a minute or two, and then make your tea in it. You'll get a more aromatic cup of tea. Speaking of which, if you use a travel cup, take the lid off at some point while you drink it because you really want the whole experience, which includes what the tea smells like. So take the lid off, in a safe place. Use loose leaves. Again, you'll get more exposure. You'll get a better cup of tea. I'm going to point out I'm in a mixed marriage. My husband uses only tea bags. He cannot be bothered with a tea infuser, and certainly not with a teapot, but not even a tea infuser in his mug. Like he opens the cabinet, takes out his bag of Earl Grey, drops it in, puts the water on top, and that's it. That's as much as he's going to be bothered with. But if you can, loose leaves are great, and use a large infuser. And if you let it overbrew, that little bit of salt, I know it upset the Britons, but it will work. And if you want the funny last bit of the story, is that there was a black tea shortage in Britain some months after this all broke, and the same newspaper that had excoriated me for suggesting salt in tea had a series of suggestions to how to make your tea last longer. And if you overbrew it, the article said, a little salt will rescue it, you don't have to dump it out. So I feel finally vindicated. But the perfect cup of tea, despite my shocking claims, is what you enjoy, salt or not. And I'm going to thank all the people who make this possible. So the Mallory Professorship, the NSF, the Klaus Fund, which funded some of the early research on this, and various editors who encouraged me to burrow around in weird places. Stuart Cantrell, Gavin Armstrong, Laura Helmuth for Slate and the Washington Post, Sabrina Vorvulius, Guy Consolmagno, Helen Arms, who strong-armed me into finally writing that book, and in the end, my students, who were willing to listen to a lot of stuff about tea. And I thank all of you for your attention. Happy to answer questions. I'm happy to answer questions about the specific teas I brought over there. If you read the book, every chapter has a little tea pairing to go with it, to drink that matches the chemistry in the chapter. So I can tell you a little bit about that too. And thank you.
Okay, we can share, right? Yeah. We're good at that. I just want to thank you, Michelle, for a wonderful talk. So delightful, right? So engaging, even if you're not a chemist and have no idea what the molecules are or what they're doing. I think we got some insight into that, and it's really been fun. So thank you very much. But it's time now to ask some questions if you want. And so I'll bring the microphone around. But then also, if you are on Zoom and wish to ask a question, you can write it in the chat, and I'll run back there every once in a while and see if I can, get your questions. But is there any, and I'll bring the microphone when you're ready to ask a question. Does anybody have anything they would like to say?
I was wondering if you could just say a word or two about white tea and how it's processed differently.
Thank you.
So white tea is processed almost not at all. So it's picked to be very carefully not bruised in any way and just left to dry. Is part of the reason it's so expensive, because it has to be handled really carefully not to bruise it. So if you look over there, there's a white tea over here, and it's very large leafed, so it hasn't been shaped in any way. And again, that's to try to keep it from bruising. And they are very delicate teas, but they're almost unprocessed. And the flavor is like a green tea. It's a little bit grassy. But not as much of a hay type taste. So imagine a spring grass being cut, might be a good way to describe it. You're welcome, but there's over there, some to try, and I brought extra in case people want to take a little bag home.
Good. Tom?
We were in the Azores Islands earlier this year, and there's the volcanic islands, and they have a couple tea plantations there as well. Are there any, say, rules of thumb or um, themes that go with the type of soil where tea plants are and the flavor and so forth that you could comment on?
That's good. Good question.
That's a good question. So depending on the soil teas are grown in, how much rain they get, and it turns out how much sun they get. So the caffeine can be controlled by how much sunshine they get, which is kind of an interesting thing. And again, it's, the plant's trying to produce a pesticide. So if it's, too shady, it wants to produce a little bit more because it would like to keep, it gets more bugs in the kind of damp area. A lot of the volcanic things have a lot of fluoride in the soil there too, and so you get even more fluoride in the tea from that. But every tea will taste slightly different depending on where it's grown and when it's picked, how long it's been on the plant.
I think Mackenzie has. Mackenzie?
What kind of tea do you recommend for sleeping, and how long should you drink it? How long before sleeping should you drink it?
So if you want to sleep, don't drink tea because it's got caffeine in it. And even decaffeinated tea still has caffeine in it, not a lot, but enough. For most people, 4 to 6 hours is enough time between drinking tea and going to sleep, but it's really dependent on your genetics. There are people who can drink tea and go right to bed and sleep just fine. And then there are people who can drink tea and 12 hours later are still like hyped up on the tea. So it's pretty variable. It depends some on your genetics, some on your diet, about what's in your diet. If you really want to sleep well, chamomile tea is great. No caffeine at all. And some of those herbal teas are really lovely.
So Kathleen.
I'm curious about clay teapots. I have a Yixing clay teapot, and I know it's more of a Chinese tea type thing, but have you done any research into how those impact the tea composition or flavor?
So I have a picture of one of those pots on here. So let me flip back. So these clay teapots, so that the gold one in the middle, and you can see in the lid, it's got kind of a gray interior in it. So this is an unused clay teapot. And when you use them, you want to use them with a single tea. So you don't want to keep changing the tea that's in there. And the tea gets absorbed into the clay. And then there it continues to oxidize, so it continues to make new compounds. And those are then released into the tea, the next pot that you make. So this is a pot you should not wash. Definitely not washed with soap and water, but you should not wash, and it just gradually acquires the tea taste, and use it with a single tea. So you might use it with a pu'er tea and just keep brewing the same pu'er tea in it. And you'll get more antioxidants in there as time goes on. The cup of tea will be richer in those. I haven't decided which tea I want to commit that pot to, so that's why it's still unused. But that's a great question.
Thank you. I have a question about tea in comparison to coffee, and whether tea is going to have a lot more chemical compounds than coffee, or, I mean.
Yeah, so coffee is also something that's got a lot of chemical compounds in it. Probably, I think, not quite as many as tea have been identified, but still these things are incredibly complex molecular mixes. And we tend not to think about them. We think, have these compounds been tested? Everything there has not been tested. Nobody really knows what the effect of every single compound is, or on their mixtures. Thank you. Welcome. More questions? Yeah.
I was interested in the remark you made about caffeine and drugs as a drug and treatment for Parkinson's patients. Can you tell us more about that, or the source, or how far along they are?
They're not as far along as I wish they were. And in this, I will say that I have Parkinson's. And so I'm invested in this research. The biggest thing they've discovered is that these class of compounds can cross the blood-brain barrier. And that's the first step in getting drugs into the spaces where they need to be for something like Parkinson's or things like Alzheimer's. People who drink tea, particularly highly caffeinated teas, are less likely to have a neurodegenerative disease. I wrote about that in the book, and then 6 months after the book was published, discovered that I had Parkinson's. So it doesn't always work. But it's pretty early days for that. More questions. Is there anything online, Kathy? Okay, I'm going to give you the microphone.
Run it back and forth. Okay, well, that's good. All right, now see if I can do this. Okay, so does the chemistry of tea bag enhance or diminish the taste of the tea? Do tea companies check the composition of the paper used in the tea bags? How often are quality control measures implemented? Did you say that anyone suffering from kidney stones should not drink tea? And is green tea better than black tea?
Boy, there's a whole bunch of questions there. So one question is about the tea bags. And the tea bags will, in fact, take some of the flavor out. They're made of paper. I'm sure the quality is good, and there are quality control things in it, but I don't know much about that. But it's the same kind of paper you use to filter out chemicals in the laboratory. So you get a little bit less flavorful tea if you have a tea bag. I'm not a physician, so I'm not going to make any recommendations about tea drinking and kidney stones. Talk to your doctor about that. I know what the literature says, but I'm not going to go there. What else did I miss?
How does the chemistry of the mouth affect the tea?
So you have all these receptors in your mouth. Big ones, we have a lot of receptors for bitterness because evolutionarily, a lot of bitter compounds are not safe to eat. So we're really high on making sure we don't eat too many of those. There's all these weird tests, including for astringency, one called the double tongue test, where you put one compound on one side, pure water on the other, and then stick your tongue in and out of your mouth for 30 seconds, and then you assess the astringency of the two. I will admit I have never tried this, but the Monell Senses Institute in Philly does all this sort of work. So there's a lot known about that.
So here's a comprehensive question from a woman who was a chemist in school. And she says, just as cheeses and wines go together, what goes best with the different teas? So are there teas that you should couple with certain foods?
Oh, so I did a whole thing this summer with Josh Smalley, who was a finalist on the Great British Bake Off, the Great British Baking Show in the US, who's also a chemist. And so the Royal Society hosted us for a tea and cake pairing. So ginger cookies are lovely because some of the compounds in ginger also match some of the compounds in tea. Floral things are, he made a lovely Earl Grey tea cake that paired well with any of the teas. Lemon is another flavor that goes on, again, because some of the compounds in lemon match some of the compounds in the tea. And so you get sort of a richer flavor with them. So there are some good pairings with this.
Are there any more questions here? Because I think we're finished with the, oh, good. Okay, one more at least.
I just want to start where you began, and that was when you read that letter. And I wanted you to, did you think it was real? Can you just give us yes, from the embassy, yes.
That was crazy. And yes, I wondered if it was real. And my publisher called me or sent me an email saying, did I have any comment to respond to the US Embassy? And this is when I was walking back to my office with that query from the New York Times. And I was not sure it was real at all. So before I talked to the New York Times people, I actually emailed the publicity people for the publisher, and I asked exactly the same question my sister did, which is this real? So it was pretty unimaginable. We thought the book would do well with chemists, And so, but the first printing sold out in less than a week. So I didn't actually see a physical copy of the book for almost a month. And when I did, I came back from teaching class, and 3 of my students were standing outside my office, each holding up a copy of the book and to get signed. And that's how I first saw the actual paper copy.
And here's another question.
I want to thank you again. It was such an enjoyable. Can you speak a little bit to why salt takes away the bitterness, like chemically?
I spent so much time tracking that down. I'm really happy to talk about it. So it turns out it's the sodium ions in the tea block the perception of bitterness. And there are a number of compounds that will do that. Zinc will do it too, although it makes things taste terrible. And sugar will do it too. So sugar in tea also blocks the bitterness because it blocks the bitter receptors on our tongue. But the sodium interferes with it in a different way. It doesn't physically block the receptor, but it sort of changes the structure of the receptor. And again, structure and function are related to each other. And there's a beautiful set of papers looking at simulating this. And it's the coffee chemists who were really interested in it, because coffee drinkers have known this for years, that if the coffee's getting a little overbrewed or a little old, throw a tiny bit of salt in. And it really is a tiny bit. Like if it tastes salty, it's too much. But yeah, it's really just about the structure of that receptor.
Thank you. So that's wonderful. I think we've, don't we wish that we all went to Michelle's class for chemistry when we were in undergraduate school? That's right. That's always good. But so much detail and yet so much fun. So thank you, Michelle, once again. Let's give her a rousing hand of applause.
And all I want to say is, again, thank you for all your attention. Enjoy all the things that go with tea, and I'm happy to answer more questions. If at the end you want to grab a cup, grab one of the tea bags and throw a couple different teas in to take home with you, please do. I've got lots of extra tea bags and lots of extra tea.
That's wonderful. And thank you to the Zoomers who are here, those who signed in online. I hope you enjoyed the discussion as well as the talk. And we hope to see you again. Thank you.